This is the walkthrough video for PCTC 2023 question 4 cubes. So we're given some information about two cubes, and we need to figure out if they intersect, and if they do intersect, we need to figure out what the volume of the intersection is. So as always, let's go to the easy bit, which is taking in our inputs. So we're going to get the x coordinate for cube 1, the y coordinate for cube 1, and the z coordinate for cube 1, as well as the side length for cube 1. And let's input this 4 times, and let's just repeat the same code up here, but with 2's to indicate that this is a cube 2. And so all we're doing here is we're just taking in eight inputs, and we're just using this list comprehension just to take it in easier. Okay, so now we have our 8 numbers. Now the hard part, now the actual computation. So the first thing to do is to check whether they do intersect in the first place. And to demonstrate how we can do that, I'm going to deal with 1D first, in one dimension. And so one dimension, let's draw a one-dimensional axis, which is just going to be that. And now let us draw a line. So let's say that's a line. Let's say that's 3 and that's 8. And those are the coordinates of our x-axis. And now let's say we draw a second line. That's going to be that. Let's say that is 4 and that is 11. And so the question is, how do we figure out whether the second red line intersects at all with the blue line? And let's actually make that even clearer with another example. Let's say we have a third line here. Let's say this line is, let's say that's 10, and this would be, let's do that above, that's 10, and this is 12. So how do we check in code whether the red line intersects with the blue line, and whether that purple line intersects with the blue line? And this is relatively easy, especially in one dimension, because all we need to do is check whether the starting coordinate of the second line is smaller than the ending coordinate of the first line. So because 4 is less than 8, these two lines intersect. But because 10 is bigger than 8, the purple line does not intersect with the blue line. And that's all we do, right? We just check whether the end coordinate of one line is bigger than or smaller than the starting coordinate of the second line. And this logic can be scaled up to all 3 axes. So this is only the x-axis, but what we can do is we can literally just, let's say we draw a y, and now we're going to deal with squares. But the same logic applies with squares, right? If this corner is, if the x and y coordinates of that corner are both smaller than the x and y coordinate of this corner, then there is an overlapped region. And again, you can apply the same logic to a 3-dimensional grid. And so even though this is really, really difficult to imagine, all we need to do is we need to check how it works in one dimension, and then just repeat the code 3 times for each of our 3 axes. I mean, you can do this in 10 dimensions as well. Humans can't even comprehend 10 dimensions, but you can write the code to do this in 10 dimensions just by literally just copy pasting that same line of code with a different axis labeled instead of x or y or z or whatever letter you're using. And so let's demonstrate that now. Let's do our very first thing, which is to check if the 2 cubes intersect each other. To do that, we need to check if, as we said, so if you just deal with the x coordinates, that's going to be if our second cube's smallest x coordinate is bigger than our first cube's biggest x coordinates, then there is no intersection. So if this if statement is true, there is no intersection in the x-axis. And we have to do this extra bit here just because we're not actually given the coordinate of the biggest corner. So we have to calculate the coordinate of the biggest corner by adding the side length to our starting corner. And let's just apply that same code to y and also z. And this is what I mean when I say if we do it in one dimension, we can much more easily do it in 2 dimensions or 3 dimensions. Let me just make sure these labels are all correct, like that. Okay, so if any of these 3 things are true, then that means at least one of these coordinates or one of these axes has no overlap between the 2 cubes. And so if at least one of these is true, there is no intersection between the 2 cubes, and therefore we print out to 0, as the question says. Now let's run this else statement if there is an intersection. And this is another hard bit, right? So we know there's an intersection, but how do we calculate what that intersection is? So back to our line, one-dimensional line analogy example. Let's say we had this again. Let's say that's 3 and 11. And let's say this is 5 and 10. And let's create another one. Let's also make that purple. And let's say that is 8 and 15. Okay, so we've got a load of lines. Now, how do we check what the overlapped region? So we already know they overlap, right? We already know they do overlap. So how do we check what the overlapped region or the length of the overlapped region between the blue and the red lines are? And we do that by taking the inwardsmost coordinates, right? So the inwardsmost coordinates between these two lines, that's going to be this 5 and this 10. And so that 5 to that 10 is the overlapped region of these two lines. And so the length of that is obviously just going to be 10 minus 5, which is 5. Now let's say we want to do the same thing, but between this green line, that red line and that purple line. Well, how do we do that? We can take the innermost coordinates. The innermost coordinates is going to be 8 and it's going to be 11. And then to find the length of the overlapped region, which is just that bit, that's going to be 11 minus 8, which is, of course, 3. And so to try and quantify this into a more rigorous idea that we can actually code up, we're taking the biggest starting coordinate and the smallest ending coordinate, because those two coordinates are the inner coordinates of our line. And then we just do the bigger one minus the smaller one to get the length. And similar idea as before, right? We can scale this up to not just the x and not just the y, but even the z axes. And so we just write the line of code for the x coordinate, and then we copy paste that line of code for the y and the z, and boom, that's our 3D cube sorted. So let's do that. Let's calculate the starting point and the ending point for the x-axis. Starting point is going to be in a 1. So let's say x start. That's going to be the maximum of both starting coordinates. And what's x end going to be? The ending coordinate is going to be the minimum of both ending coordinates, which is x1 plus s1 and x2 plus s2. And this is all we need to calculate or to figure out the starting and end x coordinates. And of course, because this is 1D and now we're talking about 3D, let's copy paste the exact same code, change all the x's to y's there. And again, we're going to copy it again as we have done down here, change all those x's to z's. And now all of a sudden, we've basically finished our code. Now we just need to calculate the overlapping volume. And here in this case, it was just bigger one minus smaller one, or end minus start. And it's a very similar thing here. So it's going to be x end minus x start multiplied by y end minus y start multiplied by z end minus z start. And let's just print that out because that's going to be our answer. Oops. So we're treating each coordinate or each axis separately, and then right at the end, we're going to combine them all together just by multiplying them to get the final volume.